And so in today's video, we're going to go over what I think is the most underrated stat in football, which is expected threat, how this can be used to build an attack momentum chart, and what we can learn from this to build our own one in RStudio. So before we get started, we need to discuss what XT or expected threat actually is, so that we understand a little bit more what we are dealing with here. So what you see on the screen now might look like the biggest load of garbage you've ever seen, but it's actually incredibly important to how we can build our own attacking momentum chart and expected threat model. So as you see on the screen, there are a bunch of numbers, and these numbers actually correlate to positions on the football pitch, which all have a separate code. Let me explain to you in a visual detail what I mean. I'm going to use this video here by Tifo Football by The Athletic. Go and check them out. So obviously this is the video I'm referring to. I will obviously give them credit in there. But as you can see here, every position on the pitch has an assigned number onto it, as you can see in this video. Watch the video if you want to find out the full detail of what actually expected threat is. But this is how I learned it, and then if I was able to make an understanding and build my own attack and momentum chart. So as you can see here, the numbers go from smaller numbers here on the left hand side to slightly larger number here on the right hand side. And essentially this is your defensive period here. So this is where the goal would be if you were defending, and this would be the goal you're attacking. Clearly, the larger the values, closer to the goal you're about to score at, and the smaller the values, closer to the goal that you are defending. Essentially what it means is each position is assigned this metric, and if you pass the ball, for example, from this here to this bit here, you get an increase of 0.01 from 0.004 to 0.014 is an increase of 0.01, and therefore we're saying how much the expected threat is increased by making that pass. It could be a pass or it could be a ball carry. So for example, I could dribble it from this zone into this zone and get a 0.03 increase. That's how it works. Essentially what you're modeling is the intensity of each attack in the sense of how dangerous and how probable a team is to score from the position they move to on the pitch. The reason we use this method a little bit differently to expected goals is because if we refer back here to our expected goals model here, so 1.74, 1.05 for each team in this Milan versus Pisa game, essentially all expected goals does is finds it sums up the expected goals per shot of every single shot in the game, which is the probability the goal should be scored given a bunch of metrics like goalkeeper position, where you are on the field, the foot it lands on, etc. Loads of different metrics that quantify how likely you are to score a goal in that situation. However, not every single attack leads to a shot action. Therefore, you could have a really, really dangerous attack and not get a shot at the end of it, and this wouldn't register as an expected goal because technically there's no shot at the end of it. This could get pulled right across the box. You could dribble all the way down to here and square the ball across the box. The strikers could all miss it, but it's a huge opportunity in the game, but it doesn't actually get registered as a big chance in the game. And that is where expected threat comes in a little bit more useful because it takes into account all of our attacking actions in the game. So referring back to the model that we have on the Athletic, what we can say here is we can say that we can quantify when a team is most likely to build a strong attack moving from lower zones to higher zones, or an increase in expected threat despite not getting a shot at the end of it, or even if they do get a shot at the end of it, it still takes into account which team is more likely to score given that situation. That's essentially how this thing works. And as I say, this focuses on stuff like carries, which is when a player obviously dribbles with the ball, or it could also focus on when a player passes the ball and progressional passes in there, which is probably why progressional passes has become a bit more popular in the modern day. So what we're going to do now is I'm going to show you how you can also build your own one in RStudio, so we can get something a little bit like this attack and momentum chart that we can see on the screen for Milan versus Pisa. And essentially what this allows us to do is then predict football matches off the back of it. So as you can see here, if we were to predict football matches, naturally what you can see is areas of high threat are more likely to get a goal. Obviously in this game it's not a great example because Milan obviously didn't score with loads of chances, managed to get a goal at the end. But if I refer back to a game on Monday night, West Ham versus Brentford, I'll show exactly what I mean. Okay, so on Monday gone, it was West Ham 0, Brentford 2, and Brentford absolutely battered West Ham. As you can see, first half specifically, the XG was quite high, and if you look at that first half, the XG was absolutely huge. 15 attempts on goal in that first half. But what you can see here is if we focus on attack and momentum chart, what you can see here is we can see West Ham started the game well. And this is why this is the best metric you can use, bar watching the game. Obviously, watching the game is the best metric you can possibly use to predict football matches. But if you're not going to do that, the best method is to use this method. Because what we can do here is rather than just getting an idea of shots or possession, or even before then, it would just be the score. Obviously, it has progressed over time to get XG, expected assists, etc. But this now lets us see, if I was to see this without even watching the game, and I just turn this on, I can see West Ham started the game decently well. on top for a little bit. Then Brentford had a little bit of a spell in here. Then Brentford absolutely battered West Ham in this zone here, which we're going to see a lot and very, very dense period of Brentford pressure, which ended up leading to a goal at the end of it, despite not scoring in this period here. That allows us to predict football matches because we can see here where Brentford are clearly on top, and therefore the probability of them scoring is extremely high, and therefore they did lead to a goal. Again, in the second half, it started with Brentford, went a little bit cagey, nothing much happened, but again, West Ham had nothing in the game. This spell here was quite busy for Brentford. Obviously, they failed to score in this zone. They pushed a bit towards the end, and then it sort of faded off in the final periods, but they scored a late goal as well. But essentially, this bit here gives us a strong probability that a goal is going to be scored specifically by Brentford. So when we're plotting these things, essentially expected threat is modelled for each team, and it's given a value between, let's say, an arbitrary 1 and -1 in here. A positive value would mean West Ham like to score, and a negative value means that Brentford like to score, and that's how this gets plotted on a graph from 1 to -1, hypothetically, depending on the range that the software uses. So, for example, SofaScore or FootMob or OneFootball might all use different heights in terms of their their graphs that they're going to plot. But what you need to see is how exactly we can plot ours. So I'm going to refer to the following article. This is an article on Medium again. Check this out. I will show on the screen what this is we're referring to. But essentially, he shows how you can plot this in Python. I prefer to use RStudio. Oh, let me just not sign in. Just press the X in there. So I prefer to use RStudio because I'm more compatible with it in terms of, because I did a statistics degree and I work as a data analyst, I use this a lot more. But if you prefer to use Python, you literally can just use what he used in the video here. But I just think it's important to actually understand how this works before you even start coding. So that's why I've gone over expected threat. In this section again, he does display this sort of ideology of how this works. Taking this sort of range of values, and that's the one we're going to refer to in this video. So if you take these range of values, what I've done is I've taken the one in this video where it says the file with the same grid can be displayed here, and that is what I've converted into a notepad document. So refer to this essentially is the zones on the pitch and the adequate expected threat value, or the numerical value that they assigned to them, given the one that he used in his video, or in his article, I should say. I then basically followed his steps and used my understanding of why I understood expected threat to be from the video that we watched before. And essentially what I did then was I was able to then make my own attack and momentum chart, as you can see on the screen now. Okay, so I'm going to show you more detail, obviously, how this works, but hypothetically, I'm just going to run this article here. So select all and run. And as you can see here, all it does is runs through everything that we need to see in our video. And essentially what it's going to do is then plot this thing on the side here. As you see, it's like a momentum chart. If I zoom in and I'll show you this a bit clearer, then as you can see here on the plot, you can see an attack and momentum chart for Bayer Leverkusen versus Werder Bremen. And if we actually go and refer to the one that was actually of what happened in the game, again, it finished 5-0. So let's go and find the game. Okay, so this was the game that we're referring to. Leverkusen 5, Bremen 0, where Werder scored the hat-trick. And as you see, this attack momentum chart that is on SofaScore. Obviously, ours won't be exactly perfect with this, but to get a good ideology of how to do it and how we actually understand it is important. So this is what they made. So what I'm going to do is open up both of them on different screens. Okay, so that's probably the best I can do in terms of getting it side by side. And as I said, it's not exactly perfect, but it's a good idea of what exactly we're doing. So you can see that Leverkusen were quite dominant in the early stages. Ours is slightly higher here, but it's still fairly accurate. Then a little spell just before the goal for Bremen, and then obviously the goal came. And straight after the goal, there's a high probability of a goal for Leverkusen, which is the spike we can see here. Then a tiny bit for Bremen. Then Leverkusen dominated again. Then just for half time, it was Bremen. And then this is the half time period here. I don't know if you can see that, but there was actually minutes on this if I just fix this. There you go, back to scroll up slightly. But as you can see here, the half time part is just here. So if we just scroll up from the half time, you can see this just after this peak. And then you can see that it actually was Bremen at the start of the second half, which is exactly what we get here. And then just before the goal happened, you can see that it was Leverkusen, which is what we get here. Then Leverkusen extremely dominant until this period here. The 2 goals and then a little bit of Bremen, and then the last 2 goals here were straight afterwards at this power of peak. And obviously, naturally, what you can see here is this 90th minute. So there was probably a little bit of spell where this is kickoff, and then it's just doing another goal again. So it's not 100% accurate, but it's a very, very good depiction of what we actually think happened in the game based off the expected threat, attack, and momentum chart that we've been able to plot in RStudio just using data of progressive passes, carries in StatsBomb. So let me show you exactly how we've done that in there as well. Okay, so for the purpose of the video, this is where the demonstration starts in terms of the live follow along. What I've done is I've made a new file there called untitled1, just so we can start this from scratch and you can follow along exactly on how you create this step by step and build your own attack and momentum chart in there. Okay, so the first thing we're going to do, I'm just copy it in there, is to import the libraries that you need to use in there. Obviously, I've already got them, so if you don't already have them, this is what you need to do, is this little bit of code here, and obviously change your stats bomb or dev tools or whatever it is that you need to put into RStudio, or just to install.packages depending on what you've already got. I've already got this, and I've already got StatsBomb, DPLRY, LYR, sorry, ggplot, and zoo. But basically, import all the libraries you need to. If you don't know how to do this, you can obviously go on Google, or you can just put install.packages and then the library, or then just put the library, then do this once it's working. I say if that doesn't make any sense, Google should do it for you. But this should work in there. Once you've done that, so what I'll do first is obviously to run each line, all you need to do is just control and enter. So I'm going to press control and enter on all of the libraries, just make sure I've got them in my file. And then I'm going to go comps, and it basically gets free competitions. This is where we're connecting to StatsBomb's API that we're going to use in this video. All the data is publicly available and just not meant for any commercial use, so we're just going to use it to play around with. This is exactly what we're doing. So if we run that in there, comps, free competitions, obviously this is where they stress you can't, just basically public use, not to use in any like commercialized features. So comps here, what this does is this opens the following thing here. As if we open this, gives you a list of competition ID, season ID, the country name, etc., and the league that we're interested in, all the leagues that they've got available. This is obviously just a free version of StatsBomb's API, so there isn't every single league available. There probably is most leagues you can think of. So the Premier League probably is in there, but it'll probably be one league, yeah. So 3-4 in 2015-16, which isn't great to compare to because the attack and momentum charts weren't actually that big, obviously. But then, but one of the good leagues for as you've seen in the video is the Bundesliga. This is 23-24, so that isn't last season, but the season before, which isn't awful. So what we're going to do is, for the purpose of the video, we're going to just focus on the Bundesliga because it's just the easiest to do in there. What we're then going to do is then we're going to reference the Bundesliga, and basically all we're going to do for that is we're going to basically take comps, which is obviously what we just took, and we're going to filter this by when the competition name in comps. What this bit here does, this little dollar sign, is it chooses the column name that we're interested in, the variable that we're interested in, from the comps data frame. So in this instance, we're interested in competition name equaling Bundesliga, as you can see from this comps thing here. So as you can see here, it was Bundesliga, and we're interested in the season name being 23-24. So that's how you do this. And here, all we're doing essentially is filtering it. So if I do this here, and then if I was to run this Bundesliga thing, so Bundesliga, and if I was to run that in there, you can see here I get just the one we're interested in. So it just takes this one season, Bundesliga 1, and that is the whole data frame. It's just of one observation rather than being of the X amount it was in that one. So once we've done that, we then want to return all the matches in that Bundesliga season. So all we're going to do for that is literally just go matches, and then we'll take that as free matches, Bundesliga, obviously Bundesliga being the variable that we just stored up here as Bundesliga. I'm just going to run that in there, and this again will get us the same sort of thing. So if I was to run matches in here, what you can see here is that we get a list of all the games, so up to 34 entries. I've said that isn't every game this season, just all the ones they've got available on StatsBomb for all this. And as you can see here, all we need to do is, if we go along, you can see, for example, one random one here is the first game here is the one we're interested in. So that 5-0 game, and you can see that if we look at the teams that were involved in it, it was Bayer Leverkusen, and they were playing against Werder Bremen. That's everything that we need in there. Obviously, there's loads of different columns. There's 42 different columns in there, so you can get to know all of them. Obviously, I don't need to because I've already done it, but you can get to know them if you open it up and then just open it on the side here. So if I was to open matches, as you can see here, that's how I can see that if that interests you. So you can see everything there that you need to see. Now, for example, if you wanted to then just filter this by a certain team, obviously we know that Leverkusen game's top, but we were only interested in Leverkusen games, for example. What we could do is just do this. Again, what we're doing is just a little filter in there. So taking this matches data frame that we've just created, and we're filtering it when the home underscore team dot home underscore team underscore name equals Leverkusen. So essentially we're just filtering this for Leverkusen games when Leverkusen are the home side. So all I need to do is run that in there, and what you'll see now is if I was to open Leverkusen underscore home, I would basically just get all the games. So only 17 entries now, which is basically just all the games where, if we go along, you can see that the home team, when we get there, they'll all be Leverkusen. But again, that's only if you're interested in it. We're going to do it for the purpose of this video, but you don't really need to. So what we're going to do now after we've done that is if we go back to We're now going to basically pick a game from that. So what we're going to do here is just do match underscore row. Essentially, all that is we're taking the first game from our Leverkusen dataset. So again, in our instance, that's going to be the Werder Bremen game. It doesn't have to be, but we're just going to filter that to be the first game, as you can see here. And then all we're doing is get free and the match row, and that basically just takes that game and gets all the data we need there. So if I get DF there, it's the data frame, and that gives all the information that we need for that game. So if I open up DF in here, what you can see here, this has literally every single thing that happened in the game as an index, a period, a timestamp, absolutely everything you possibly could need. Any related events, the position under pressure. Honestly, there's so many in there. I don't even have time to go through all of them. Literally, like they go Nick Voltemada, right centre forward. What did he even do here? A ground pass to Marvin Dush. That's literally all it was. Right foot, probably was from kickoff or something. I don't have a clue. It was in the first minute of the game. So every single possible thing in the game is stored in there, and that's where we're going to take into account our carries and our passes that we're going to use in our expected threat model. Okay, so this bit is vital if we're going to do it. So what I'm doing here, don't be careful when you're copying this because you actually understand what I'm doing here. So what I'm doing here is I'm reading in a CSV, which is potentially called xt_txt, and that is our text file that we have earlier, the one you can see on the screen now. So what you can do is obviously if you copy the figures in there, you can get it online by going to that Medium page or the link, or I'll just put something in the description that allows you to copy them. Essentially, all you want to do is just take these figures, save them in a text file as I've done here, and then you're going to call that xt_txt the same way I've called it. But the most important thing is you then need to save that in the same location as your RStudio file before you actually run the thing. I'll show you what I mean by that. So as you can see here, our xt_t is a text file that's saved in the same place as we're interested in. And currently, obviously, we're using untitled one, but the file that I'm referring to this from is called plotting at mom. And essentially, all you need to do is make sure that you definitely save this in the same location. Otherwise, this next part won't work. So just make sure you do that. So what I've done here is obviously, before you read this in, what we're now going to do essentially is we need to save our document. So obviously we're going to save it in the same location again. Okay, so I'm saving it again in Predictive Football Attack and Momentum. I'm going to call this the same name and then literally just call it version 2. And I'm just going to save that. You literally call that whatever you want to call it, but I'm just going to save that in there. Okay, so now I've saved it. What I'm then going to do is I'm going to go to this. There's a button at the top. You probably can't see it on the screen, so I'll just scroll down. So this button here, it says session. I want you to press that button called session, and then I want you to go to set working directory and press to source file location. So you press that in there. What you then get is this bit at the bottom here where it says set working directory to there. What we're going to do is we're going to then copy that. I'm just going to place it at the top of our file. What that essentially means is every time this file is run, it essentially sets the working directory to be the location where we've saved our RStudio file. That means that we can call stuff like this, so our expected threat model, without having to call it every single time from the file explorer name. We literally just call it and it's saved as expected threat, and it means our RStudio file can find this rather than having no idea where to look on our computer. If that makes any sense. I know it's a little bit complex, but now that means it's going to work. So all I need to do now is, because I've set my working directory, if I just run that line in there, then what I'm going to do is I'm going to go down here and expect the threat model, and I should be able to read it in because we've already seen it. And all I'm doing now is I'm reading in our expected threat text file. Just going to resize in there. And once I've done that, I'm then going to convert it to a matrix. The idea behind this is then I can have it as a column like that by that. If I'll just show you what this means just now, if I just open up XT in here and I open it, you can see it's now a matrix where it's like 1 by 12 in terms of columns and 8 deep, which gives us our 96 different periods on the pitch, or like locations, I should say, on the pitch. Once we've done that, then we're going to basically get the rows and columns. Obviously, as we've just seen, that'll equal 8 and 12 respectively. So there should be 8 rows and there should be 12 columns. Just make sure it's definitely working. There you go, perfect in there, which will come in handy later on in the video. Now is where this gets a little bit more complicated. So what we're going to do now is, now that we've preset our data, we have our data frame which has all of our data in it. Obviously, I said we were only really interested in our passes and with our carries of the ball. So what we're going to do first is we're going to take this into account as our passes, and literally all we're going to do here is make a new data frame that specifically is looking at passes. So for example, what we're doing here is we're taking our data frame, which is obviously the data frame we just made, and we're going to filter this by the type name equals pass. So obviously type name was looking at all the different types of things. It could be a shot, it could be a pass, it could be a carry, it could be a duel, anything like that. So we're going to filter it by pass, and also we're also going to filter it when it's not an NA for the location. That means we have a final location, because obviously clearly if there's no location of the pass or where the pass is going to, there's no way we can include in our data set because we've got no idea what the change in expected threat is. So we're going to filter it by ones that definitely have a value for location in there. If I filter that in there, what you'll see here is if I open up DF passes, as you can see here, apologies, I've got an absolute bunch of things in there I probably should get rid of. But you can see here, if we go to type name, wherever it was, well, they're all ground passes. Where's type underscore name? There it is. Type name is pass. So every single one of these is a pass in there, which is good, which means it's worked. And we should have a location for all of them, which is good. And the location essentially is coordinate positions on the football pitch. So 61 and then 40.01 is obviously the coordinate, and the end location should also be in here somewhere. End location is 59 to 40.9. So obviously that's how it changes, and that's what allows us to then take this value and assess the difference in expected threat. For the purpose of the video, I'm going to get rid of any ones that are zeros in there. So for example, if there's any like sort of blank ones in there, what we're going to do, we're just going to return the data frame and just essentially just set everything equal to 0 in there. So we're not going to include that one in there. So we're just going to preset this to be in there. So obviously that basically means if it's empty or if there's 0 passes in the game, everything just gets written to 0 just in case there's an error in our data. So run that in there. That'll make no differences to us. That's just basically saying if n row, this means the number of rows in df underscore passes equals 0, then you return all these as being 0. But obviously that's extremely unlikely there's going to be 0 passes in the game. Now, if you think back to the data that I just showed you for DF passes, I've just opened it up again and we go to our location, for example. It's a little bit messy having C 61 40.01. We're kind of want to get rid of our C in there and obviously the brackets, and we want to split our thing into X and Y in terms of our X coordinate and Y coordinate. Otherwise, it's not really very useful. So that's what we're going to do next. So if we go back to our attack momentum thing in here, we're going to control and V that, and essentially parse location. What we're going to do is we're going to remove the C. So I've put little comments on this bit just so you understand what it is. We're going to remove the C from this side, and we're going to remove the bracket as well from this side as well, which is what this bit does. Then once we've done that, we're going to obviously because we know it's split by a comma, so in here you can see that it's split by the comma here. So the same as what text split would do if we were doing it on Excel. What we're going to do is just say that it's split by a comma to understand the two different values of our X and Y. We're going to convert these to numeric values, what we're doing here, and then we're going to return as a matrix of basically X and Y coordinates in there. So parse location is what it's going to do, and that's essentially a function. So that'll do nothing. It's just a function that we're going to refer to later on, but we need to just store it in there for the time being. We're now going to use that function on all of the passes, but looking at the location. Remember, the location is where the pass starts from, and the end location is where the pass obviously finishes. So what we're going to do is this line here. So what we're going to do is literally convert this to a matrix in a minute, but by running this line, what you can see here, if we do lock underscore mat, you can literally see it's going to run that function on the location value of everything in the DF passes thing on the location column. So if we run that now, what you can see here is every single pass now there is being split up. So you got your, if we go back to here, you've got your X value, which is in 1, and your Y value in 2, and now it's split up for every single value in there. So 61 and 40.01 was our first one. So rather than having it as C61 40.01, we've now split it up so we can really easily access each one of them in there. So what we do here is we'll go back to here, obviously we'll get rid of that. And what we're going to do is we're now going to define our X and Y's in there. So simply by doing this, our DF passes underscore X is going to be our X location of the initial pass, and that's going to be the first value here. So we'll filter in this matrix by this in here, which is obviously these values here. Obviously you've got your rows and your columns in here as well. So what we're going to do here is simply just do this for X's and Y's, and just to make sure the first one's obviously definitely working, we're going to go df underscore passes. Sorry, I'm going to go in here. I'm going to have a look at our X and Y's. So obviously our X value should be equal to 61 and our Y should be equal to 40.01. So we just go along to the very end. I'm going to have a look here. So our X value is 60.1 and our y is 40.01, which means it's working absolutely perfectly in there. And now what we're going to do is just repeat the same thing for the end location in there to make sure that's also working. So we're actually going to run that in there. Again, I'm not going to explain everything here because I've just explained it, but you know how it works. So our end, and what we're going to do is just do the same thing in there again, and that gives us an idea of our end position in there. Again, to make sure it's definitely working, we go back to df underscore passes, and what we're going to do is go back to the beginning here. We'll find our end location if we can, 59 and 40.09. Again, go to the very end now in here, and it should be, there you go, 59 and 40.09. So again, that is working there, which is absolutely perfect. Now, probably the most complicated bit so far. This is a little bit more complex. So what we're now going to do is now we're going to associate our x and y coordinates and our end x and y coordinates with the points on the football pitch that we defined before. So we said there was 96 different points on the football pitch when we converted that to a matrix of like when we had our numbers in there. So what we're going to do now is this is a little bit more complicated, but as you can see here, we're going to do our start x bin. So essentially what we're doing is we're converting this to bins, as in like bins being like points on the football pitch. So our split of the pitch into 96 different sections is what we call our bins, essentially. So our start and end bins for each x and y is basically what we're going to do is do p min, p max as numeric. Essentially what we're going to do is obviously it was a 12 by 8 that we had before, which gave us a 900 the 96 thing. So obviously this is we're going to take 120 and 80. That's where those two values come from. And essentially we're adding 1 to everything as well, just because obviously if we're going to get 0, then obviously that's not going to be accurate, so we need to add 1 to that as well. I know it's a little bit complicated, but just copy that in there. That's the only way I can get it to possibly work. But if we then do that, what it'll do is it'll then define different sections of the pitch that each pass comes from. So this was really hard to then convert this to RStudio because the example is in Python. I knew exactly what I was doing in terms of expected threat model, but that was the best way I could make that work. It does work in there, but it's again a little bit more complicated. But essentially what we're doing for our x's, obviously it's going to be our 12, which is going to be the 12 columns are for, and there was 8 rows. That's essentially what it does. I'm essentially looking at our value of x and y and seeing which bin they fall into, essentially. Hopefully that makes sense. I know it's a little bit complicated, but that'll hopefully make sense. What we're then going to do is, now that we've defined them, we are just going to ensure that we can make sure it's definitely working. So for example here, this will give you a list of like where everything is going from each passing section to each other. It's not exactly the same as the one in the article, but it does work. So from 7 and 5, and it ends up in 6 and 5. So that's absolutely fine. We could sort of tell that by the values we're expecting before. So that's fine. We just make sure it definitely works in there. So I'm happy with that. We're now going to look up our xt values. So essentially what we're going to do here is define this. So we're going to take our df passes and we're going to have a start zone value. And that essentially is going to be taking the bins that we just defined earlier, which is what these are here, and essentially define the xt values from the list that we saw earlier. So remember the one we saw on the Athletic, which I think about was essentially this bit here, but obviously we had a text file of it on Notepad. And all we're doing essentially is looking up the value of that given our start x and y bin, and then we're also going to have a look up for that for the end x and y bin. Essentially, that's all we're doing here. It's basically just to define what our start and end expected threat values were for the initial, before the pass, and after the pass. Essentially, what we're looking at in there. So we're going to define in there, and we're going to store those as start zone value and end zone value in our df underscore passes. We now then want to define our expected threat per action, which obviously is going to be the end zone value minus the start zone value. So obviously that's the difference in our thing. So our end zone value is obviously going to be what we're currently equal to, and our start zone value is what we were equal to. Therefore, an increase in that would mean our expected threat value has gone up, given that pass has taken place. Hence, there's going to be more probability of a goal being scored in that time period. That's essentially what it means. That's all we're defining our expected threat as, essentially the change in expected threat between our pass beginning and ending. So that's all it is. Just to make sure that it works, just repeat this sort of line here, copy what I'm doing, and if you get values such as this, then you know that it is working along the same as me. So your first value, 5, 8, 11, should be something similar to this, just to make sure it's definitely working in there. Then now simply that's just done in terms of passes. So what we've done now is got every single expected threat for every single pass we've got. Obviously the minutes here is 0 and it goes up the way to 90, I believe, in there. But we're going to repeat that exact same process for carries. So if you think back to when we defined our DF passes, which is in here, all we're going to do is repeat exactly the same thing, but change everything to carries. So in here we're going to do DF carries, as you can see here. and then I'm literally going to carry everything else down and copy everything else down for carries. Again, just double check, I'm going through everything what we're doing here. So obviously we've just done this bit here, our df carries, we've defined it. Again, we're going to check if it's empty, we're going to just define everything as zeros. Again, that won't happen in there, but we'll just click through it. Our parse location is getting rid of the C's and the brackets in there, as we always did. We're then going to run that parse location function on our location data. We're then going to get our x and y values and our end and x and y values as we did before. For our carries, essentially it's exactly the same method, but rather than a pass, it's just a dribble with a ball of how we change from this section to this section on the pitch. Again, we're going to start with our starting x and y bins as we did in there. And this time what we're going to do is then do the exact same thing. Okay, so if you need to copy this data in here, literally exactly the same, except we've just changed df carries rather than having df underscore passes. We're going to look up the xt values of where they were on the pitch, given the bin values, and then get our xt for the carry stuff, and then just have a look. And this is sort of data you should be getting. Go to the first item in the data, should be something about that. If that's the sort of thing you get, then obviously that's very, very good. Okay, so what I'm going to do now is I want to just get rid of any NAs in there. Essentially what I'm doing now is making sure that any values that are not important in the data or they're completely empty in the data, we're not going to let them skew the data, so we're just going to get rid of them as they're not important in the data, and we're just going to get rid of them. That's essentially all we're doing, is filtering it by not NA, which is not an error. That's all we're doing in there. And then we're going to combine both of these data sets together. And to do that, all we're going to do is something called an rbind, essentially run that in there, and now our xt underscore data will be a list, will basically include all the passes and the carries combined together. We're then going to basically clip the xt value. I'm going to show you how we're going to do that in there. So this line here is what we do. So xt underscore data, I'm just going to clip the data, and that is p min, p max, our xt. We're going to filter it by our xt underscore data, filtered by xt, and obviously the p max 0 minus 1. So essentially we're saying that has to be between obviously those values, as you can see in there. So we're just going to clip that value, and then we're going to make sure that worked in there. So let's just make sure xt underscore data, you should get some sort of value like that for your first couple of things in there, just to make sure it's definitely working. So as you can see, Werder Bremen did start. I assume they had to kick off, which is what we'd assume this thing is in here. So now we've done that, we're going to calculate our momentum and our basically the max per minute, which is what defines this sort of thing in here. So all we're going to do is we're just going to aggregate, and what we're going to take is our expected clip thing here, and we're also going to take the team name and the minutes, and what this does here. So max xt per minute, I'm going to show you what this does. Is essentially, if we just plot this in here, and I'm going to show you what this does. This in here will have the team name, the minute, and the xt underscore clip, which is exactly what we wanted. Essentially, all we're saying is per minute in there. So that's minute zero of every, and then minute one. Shows both teams, and it shows the expected threat value per minute. And all we're going to do is go for the larger one, which obviously is the team that is obviously more dominant and more likely to score in that minute. Hence, how you can start to plot this sort of thing in there. Okay, so the next bit I'm going to do in a 4, but essentially all we're doing here is our window size being 4 and our decay rate being 0.25 allows us to make this curved smooth. That's what we're going to do here to make this look a little bit nicer than just having like a graph that goes boom, 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 like up and down lines. It looks a bit stupid. This allows us to get the curves that we need to make it look a bit more professional in there. So we're just going to run that in there. What we're then going to do is also want our home team and away team name, and that's just for this title at the top here, just to make it look a little bit better. The way we're going to do that is if you think back to match row, which is something that we got right at the top here, which was match row was here, where we took the first game of our Leverkusen data set. If we look in that thing here, so if I open up match row, so as you can see here, match row, and if we look at the values that we're interested in, our home team is this bit here by Leverkusen, and our away team is this bit here. Hence, you can have a look at the column names in there, which is why when we're looking at it, we can see here, if I scroll back down, our home team is just filtering that match row by home underscore team dot, and that's the thing we just seen, and our away team in there. Again, if you want to just double check these are definitely right, you can just look at that and say home team, and that is stored as by Leverkusen, and if you just change that to be away team, this should be saved as Werder Bremen. As you can see, it is there in there, which is absolutely perfect. Once we've done that, we're then going to look at the maximum values of xt per minute and look at which team's more dominant in that minute. So as you can see here, teams is obviously all we're doing here. Literally, is we're taking our max xt per minute, which is this thing we just plotted before, and what we're going to do is look at the two teams in there. Obviously, it's going to be the unique team names, so obviously there will only be two teams in there, so that'll just return us by Leverkusen and Werder Bremen. So we'll just do that in here, and then just do that teams thing. We'll probably just get both teams in there. So teams in there will just give us a list of 2, which is obviously Leverkusen and Werder Bremen. Once we've done that, then we're going to then sort the minutes into our unique number of minutes. So obviously that's, again, just going to be 0 to 89 in there, but it'll be ranked from 0 to 89 in order. So if we just run that in there, in here, what we're going to do is just run that minutes thing. And if we just run minutes in there like this, and I just run it, you'll see here it goes 0 to 89. It is ordered in, obviously in order. So what we're going to do now is I'm just going to get rid of this minutes thing, and what we're going to do is just look at each team and just see which team is more dominant in the time period. So we're going to create an empty list, and this empty list is obviously whenever you're building a list in RStudio, just create an empty one. So weighted xt underscore sum equals list. This will currently be empty, so just again, if I just run that in there, that'll be an empty list, a list of 0. That's all it means in there. And then what we're going to do is loop through the team in teams. So obviously it's going to loop through our teams. There's this bit here, so we're going to loop through Leverkusen and Werder Bremen in there, and all it's going to do is look with it within our weighted xt underscore sum / team. It's going to look through, and it's going to look at making the length of the minutes thing numeric. That's all it's going to do, which is our sort of this. So it's basically just going to look at that and just make sure that we sort through both teams. If we just do that in here, then it's loop through both teams, and it's just made it numeric for the number of minutes. So it's done. And what we're going to do is our weighted xt underscore team thing that we just defined as being numeric length, we're going to define that as momentum in there. And simply that momentum thing will just give us a value like this, where obviously it's currently just given all 0s in there. But that's absolutely fine. So now we're going to fill this sort of thing so we have an actual idea of momentum. We're going to use a big for loop in here. Essentially what we're doing here is for I in sequence along minutes. So as we go along in minutes, obviously from 0 to 1, the current minute is going to be the value of I. So this is obviously naturally go from 0 to 89, as you can see in there. We're then going to loop through the teams. So for team and teams, that loops through both teams. Recent is going to be the max per minute of that team, and given the current minute, which is obviously what we've just defined here. So it's going to be when the minute is, see, I'm getting all confused here, is greater than, less than, when the current minute is greater than or equal to the minute defined there, or if it's greater than current minute minus window size, and window size is defined as 4, hence to make sure it fits on the screen, etc. Then we're going to make sure that it's not empty in terms of this being empty. If it's empty, obviously the weighted sum is going to be 0. Otherwise, our weight, and this is where we're going to use a bit of our bit more complicated, our decay rate, which we defined earlier, is 0.25. We're going to use exponential function, which is what this exp is here, minus our decay rate, so define it as a minus, and then we're going to do our current minute minus the thing defined as recent in here, but defined as minutes. So our recent, and then the column minute. That'll give us a weighted sum, which is a sum of basically the weights, which is defined there, times by our xt, and that'll give us a weighted thing in here, which then allows us to define that for the team and the minute in there, and then that gives us a momentum, which is essentially taken in this value here. So what you're doing is you're taking the home team's value of a weighted sum, weighted xt sum, minus the away team's value. This will give you a value. If momentum's negative, then it'll be defined as being negative one here. If it's positive, it's positive there. And what we've done to weight it is we've just obviously taken our exponential decay rate, which is what we've done in there as well. I know that's a little bit complicated, and I hope I've explained that quite well because it is quite complex. But if we run that in there, that'll actually work now. Our momentum now will not be blank, so momentum in there, you can see that if I run that now, that actually gives us values now for all the minutes from 0 to 89. And see 0.006 is probably what this bit period is here. And as you can see, the peak in Leverkusen was probably about just after, what's that, 49 to 59 minutes. So if we look around here, you should see a lot of negatives here. As you can see there's quite a few negatives, which indicates the period of time where Werder Bremen were slightly more dominant in the game. That's how it works in there. I know that was quite complicated, but essentially we're just taking this sort of rate there, and we're just taking off the current minute minus the recent and then minute thing in there. I know that's a little bit complicated, but hopefully that does actually make sense. We're then going to store that as a data frame and plot it as an initial graph. So if I store that as a data frame, momentum underscore df, this is going to be a data frame of minutes and then momentum. Essentially, all this is literally going to give us in here, if we do the head of this, is minutes. It'll obviously go from 0 to 90, but this is just the head, which means it's the first 6 variables you can see in there, from 0 to 5. and that gives us a momentum per minute, which is what's then plotted on this graph here, as you can see there. So that's absolutely fine. We're then going to plot our momentum DF minute versus momentum just to get an idea, and this will give us not as nice a graph, but that's the sort of thing we're getting there, where it shows the minute and the momentum, and obviously that's the same sort of thing we're going to get in the minute, but it's a little bit messier, and it goes from 0.2 to minus 0.2. We probably want ours to fix between 1 and 0 or something a little bit similar to that. So what we're going to do now is to continue this. We now want to do this little thing here where we're just going to calculate the time of the goals in there. As you can see before on the graph I plotted before, you can see like the little parts where the goals are plotted on there, and I just think it's a little bit easier. It's more likely to be professional. As you can see on the silver score one, they had a little bit where they had the goal on it, so I want to make it a little bit like that. So all I'm going to do there is just take goal events. It's going to be defined as taking our data frame, our original one. I'm going to filter it by where it is. Again, not an error for short outcome, and essentially want it to be short outcome equals goal, and wanted to take the minute and the team name in there. So all we're going to do there is just take that, and I can see here our goal underscore events is just defined as the goals in there. So goal underscore events here is our minute, our minute, our minute, and our minute of the 4 goals, and so of the 5 goals, sorry, there you go, and they're all scored by Bayer Leverkusen, and they are the correct minutes. That's absolutely fine in there. I'm glad to see that's working. And then one obviously want to count the goals. So this is for this bit here. We can get all 5 and 0, and essentially all you want to do there is just make a table of goal events team name, and essentially that just counts the number of goals. So our goal underscore counts in here is just defined as Bayer Leverkusen 5, because it was 5-0. So, and now just to extract both the home and away score, all we're going to do is home score, if else home name and away name, which is what we just did before. Essentially, we're just going to look at the stuff in goal counts, and we're going to count the number of them. Obviously, in this instance, this is just going to be like 5 and 0. So home score, away score. Now, if we look at home underscore score, and run that in there, it's 5, and away underscore score should just obviously be 0. If it's basically this if else thing, just if it's if it's obviously empty, then we just define it as 0. That's all that means in there. So 5 and 0, which gives us our value in there of 5-0. Then what we want to do is, as you can see here, I've kind of got the actual goal bit written in 0.5. Again, if it was an away team that scored, I have that at minus 0.5. And all I did to do this was I put the goal events in the Y position for them. It's essentially just going to be 0.5 or minus 0.5. So if it's the home team, it's 0.5. Otherwise, it's minus 0.5 if it's the away team. Again, that's plot that. All that means there is all of our goal bits are there, just so we can actually see them and have an actual understanding of where they are, rather than them being sort of in the way here or so far up you can't see them. So that's why I did that. Now, as I mentioned before, when you're dealing with a momentum chart, essentially it's a value of positive for the home team and negative for the away team. All we're going to do to be able to do that is just put that in there. Our momentum positive is obviously the P max of our smooth momentum, which essentially means all the values that are positive, and our P min is all the negative values. So we're just going to find them in there, and that'll get us that in there. Absolutely fine. That we got an error. And then what we're going to do is we are going to just define our plot in there. It's very complex, this, but essentially all we're doing is we plot momentum df, the minute. The blue bit means that we're getting the fill in there. The red bit means we're getting the fill underneath. Want the actual line to be white is what this bit means. Our intercept there is going to be dashed, which means this line through here is dashed. Our goal segment is obviously where the goal events are. We've got our goal events again being dotted in terms of the line coming through, the circle there, and the label being goal. We're going to annotate our values obviously in there in terms of being blue for Leverkusen and red for Werder Bremen. Continuous scale for X and our Y values. So our X goes from 0 to 90 with 15-minute intervals, and our Y goes from -1 to 1. Obviously the label, the score, and the theme in terms of that, in terms of the base size, that just basically means the actual text that we're using and what we're using for the colors and the background, and also what we're using for the colors in terms of the text in there. We're just going to run that in there again. So if we run our ggplot in there and we do that in there, this will then get us what we need to do. Obviously our GM rhythm is currently not defined because our momentum underscore pos is not found. And the way we're going to do that is, so the reason this isn't working is essentially what we need to do is, before we start going to our plot, I actually forgot to even smooth the data. So after this bit here, we need to put our smoothing kernel, which is essentially what this bit is here. So if you go back to this bit here, our Gaussian kernel is what we're going to add in now, and that's essentially just fixing allowing our thing to smooth, which is what we're going to put in here. And again, we're going to do our Gaussian smooth bit again there. That then allows us to do our momentum df smooth momentum. We're essentially running that Gaussian smooth function on it, hence why we couldn't have our smooth function before. If we then plot this then gives us the following in there. Looks not much different to what we had before, but now if we then run our goal events, our goal counts, home score, away score, all that stuff that we ran before, now as you can see now, it should work absolutely perfect and we get the attack momentum chart that we wanted to do before. So apologies for that little bit there. So all you need to do is, again, as I say, just put that little bit in between where we'd originally plotted our momentum. And when we started doing our goal events, this when you add in this little bit here. And there you go, ladies and gentlemen. That is our attack momentum chart done. If we made that a little bit bigger on the screen, you can see now that we have a full attack momentum chart all made nice and simple. So all I need to do is, even if I change the game, for example, if I change this, so rather than having Bayer Leverkusen, if I just had, I have no idea, give me an idea of a game that was played that season is in the data set. Let's have a look. Yeah, I'm just going to have a look at the matches thing in here. So have a look at matches. Let's have a look what we've got in here. I'm just going to run it and we'll have a random pick of a game. Let's just pick matches and we want the home team name, whatever it's called. So home team name, I'm just going to put that in there. Let's have a look. Let's just pick the first home game that season that Borussia Dortmund had. So let's have a look. I'm just going to copy that in there just because they're there. And we're just going to take that in there. Let's have a look. And what we're going to do is run this entire thing on here, and then we should get attack momentum chart for Borussia Dortmund's first home game that we have on there. There you go. So it's against Bayer Leverkusen again by chance, and this is the attack momentum chart that we got for that. Again, double checking that it's definitely correct. Let's have a look at that game on SofaScore. Okay, so I believe this 1-1 game is the game we're referring to, 23-24. It was on 21st of the 4th, 24. So that should be the game we're referring to. That's the attack momentum chart that it has given us in SofaScore, and let's see what we've created. I've overlaid what we've made on the screen there, and I'll put it side by side. So let me just make that a little bit smaller. And there you go. So you can see the first half was dominated by Leverkusen. The half-time period was sort of when, let's have a look at that so we can get minutes. The half-time period is where Dortmund started to pick up. Obviously, I know our values are a lot smaller, but that's because I've zoomed out quite a bit. Then it became Leverkusen, then a tiny bit Dortmund, then a lot of Leverkusen, then a lot of Dortmund when they scored, then Leverkusen again. So it's actually almost perfect for that game as well, which is really, really pleasing. So hope the video has been helpful and has actually explained to you exactly what attack and momentum chart is. Again, a big thank you to T4 Football by The Athletic for explaining this video. Again, if you want to learn more, just follow their video in there. And a big thank you to the person who wrote this article, what's he called? Alex Kapich, who wrote, obviously, to do with RStudio. We get a good idea of how to actually do this in. So he did it in Python. We get a good idea in RStudio. Hope you guys enjoyed this type of video. As I say, thank you so much for all the support.